Hello all, we are going to have a look at finding solutions of trigonometric equations during this lesson. Okay, let's have a look at our first example and then I'll run through all the theory parts behind it. We've been given sin x is half. Obviously we know this one from our exact value tables. The sin 30 or sin pi on 6 is half. Therefore, one value is already done, pi on 6. This is in radians, therefore pi on 6. That's one value. What are the other values? What are the other angles gives me half? If I look at the unit circle, what I'm looking at is pi on 6 here. That angle is pi on 6. And the height is half. Now where else I could get the height half? Obviously if you went around the unit circle and if you subtend an angle which is pi on 6 less than pi, that's on this side on pi minus pi on 6 in that case, I would get same height. Therefore the next one is pi less pi on 6. Well, if I keep moving around up to 2 pi, I would not get any other value, any angle that delivers me the height half. Well, the next one that I'm going to look at is then going clockwise. We went anti-clockwise, now we are going to go clockwise. From here, I have to go all the way and then hit that point. That becomes the same height as the height here, height half. Well, what is that angle? So I'm looking at the angle all the way, that one. So earlier we looked at all the way here into the left, anti-clockwise, which was pi, which is pi minus pi on 6. See the way I look at? I go anti-clockwise and then come back. The one that I'm looking at now, the one I am interested, is the blue one all the way. So all the way I have to go pi, and then also this little angle here is pi on 6. So pi plus pi on 6. So that will be that angle in value, but because we are going in the clockwise direction, it is all negative. So basically what we are looking at is negative, and also if I put negative here, that is more intuitive. I go negative pi, which means clockwise pi, and then another clockwise pi on 6, which means again negative. Hence the answer is negative pi minus pi on 6. That's one value. And have a look at the last one, which will be all the way clockwise until I hit that point. So let me get a nice curve around the course here, just in there. Okay, all the way, that green one. How do I do that? Well, I can think of, if I use my black pen, all the way 2 pi clockwise and then back anti-clockwise pi on 6. So all the way here mean negative 2 pi. That's what I need to do. Negative 2 pi. And then because I go anti-clockwise, this is in fact plus pi on 6. Hence plus pi on 6. Therefore my final solution to this problem becomes negative 2 pi plus pi on 6. Well, I got 4 solutions where sin x is half, which means on a unit circle there are 4 different points, or actually 2 of them are coincident, with 4 different angles where the height is half. That's what it is. So let's simplify. Negative 2 pi plus pi on 6, that becomes a negative 11 pi on 6. And then the other one, negative pi, negative pi on 6, that's negative 7 pi on 6, and then this one pi on 6, this start, and then finally we have pi minus pi on 6, 5 pi on 6. Well, we got the answers. Now let's have a look at how I solve this one using a graph. Well, I'm looking at the height half. I know the sine graph, and I'm looking at the height 0.5. You can see it's in there. I'm going to draw a line that goes through 0.5 and find all the points that gives me height half. Well, the very first one, you can see it comes down to pi on 6. We found it. Let me get different colors, matching colors as I did before. So that one, pi on 6. The next one is pi on 6 less than pi. That is this one, which is 5 pi on 6. So the height is half here, again down there. Now we go to the negative side. When you are moving around the circle clockwise, I would not get any here, but I would get one right after negative pi. So that is here, this color just in there. Down here you can see negative 7 pi on 6. I have given all the values on the number line so that you can easily create those values, or just write by looking at. Now the final one into the left will be that one, just pi on 6 into the right from negative 2 pi is negative 11 pi on 6. Here we go, ladies and gents. That's how you find using the graphical representation here, using the graph. Right, let's keep moving into the next one. Cos x is negative half. Now we are going to look at a length becoming negative half. The length is, you're going on a unit circle around the circumference, and you're going to the negative side, and you can see the length is half in here. In this case, negative half. Oops, it's a little bit off here, so let's get that there. There you go, negative half. That's close enough. Negative half. In that one, what we are looking at is the matching angle on this side that gives me half. So that's what it is, either 60 degrees or pi on 3. Then what, this also pi on 3. Hence, what is this red angle? It's pi minus pi on 3. Pi less pi on 3. So that's one solution. This is 2 pi on 3. That's our very first solution, in fact, just in here. And then also, if I went further down on the graph, I get to a point here down which has a negative height, but it would have exactly the same negative length from the center here, O. Now in that case, this value is pi on 3. Now you go all the way pi plus pi on 3. Hence, pi plus pi on 3. That becomes 4 pi on 3. Now I got two solutions. Now what I have to do is I got to keep going, because it says you can keep going until 4 pi. I'm going to complete a one full circle to see whether I get same length. I don't, because they are the only two in one full circle or one full revolution. Now I'm going to go all the way one lap anti-clockwise, and then I'm going to go on the second lap. Now I hit this again. Now you can see they're exactly the same two values as we got here when you pass, but it has done one revolution. So he has done 2 pi already. Therefore, what do? I simply add 2 pi onto each of these. Those will yield my other two values. If I add 2 pi onto 2 pi on 3, 2 pi, that indicates the one revolution, full revolution. Then 2 pi on 3. Then the other one again, 2 pi plus 4 pi on 3. Then we can write down the answers. 2 pi on 3, 4 pi on 3, and then when you add this one, 8 pi on 3, and then this one you get 10 pi on 3. Just converting these additions as a in here improper fraction, right? Okay, they are the solutions for that one. Even if you look at using the graph, you are going to have a look at a negative height in here. So if I draw a line that goes through negative half, and you can clearly see the graph cuts at those points and delivering us the appropriate values. And then here between 0 to 2 pi I get two of them. One is just in there, 2 pi on 3, and then the other one is exactly same distance of 3 pi on 2 to the left. That gives us 4 pi on 3, and then I repeat these two figures with 2 pi. So every time when you go one full revolution, you add 2 pi. That's how you generate the rest. Okay, right, so we done that one, and we are going to move on to the next one, where we are having equations here. There's nothing else. Okay, let's have a look at how you solve these based on these equations. Okay, right, sine theta equals √3 on 2. Well, I do have my first value. From your exact value table, it becomes 60 degrees. Sine 60 is √3 on 2. Oops. Therefore, theta has to be 60. The next value, or the next height that gives me on the second quadrant, if that is 60, and then the other one is 60 here. So in the second quadrant, I would get exactly the same height. If that is 60, that is 60. And the angle that I'm looking at here, the blue angle, is 180 minus 60. What is that? 120 degrees. So we found the two solutions, no other before 360. That means in one full revolution, you would have two solutions. Okay, this one. Cos theta equals -3 on 2. We are asking, give me the length with -√3 on 2 into the left, but I know what gives me √3 on 2. √3 on 2 is from 30 degrees. Then this should be 30. What it means for us as an angle that delivers me -√3 on 2, theta, the very first one is 180 less 30, 150 degrees. And then if I look at the next one is just in here, and if I go a bit further down, that will be exactly the same way. Here 30 degrees, but in this case I'm looking at 180 plus 30, 210. So these are the two solutions to cos theta equals -√3 on 2. Well, the final one, you can see they're all in one side. Now you need to rearrange such that you have the circular function on the left, and then you move the rest to the other side, √2 on 2. Well, this is a -√2 on 2. If I look at this one in the same manner as I did before, I'm going to look at my unit circle. This is pretty handy to do, and a rough sketch will do. √2 on 2 is always with 45 degrees, then -√2 on 2, the height we are looking at, not the length. Therefore, you gotta go all the way until I hit -√2 on 2 height, which means 45 degrees down that way anti-clockwise. Once I have already done 180, so I gotta do 180 and then plus another 45. So you gotta add them up, all of them. 225 is your very first angle for theta that gives me -√2 on 2. And then the next one, all the way, you just keep going until I get exactly the same height just in here. And you can see with the symmetric property, this is 45. That means 45 less 360. all the way is 360, and this is 45 less 360. Then you can write down the answer, 315. And we are looking at these answers to be inside or within 0 to 360, which means we are done. We get 2 solutions for each of them. Right, ladies and gents, that's all from me. Happy learning. Work on the work planner, and I'll catch you on the next session. All right, have a good one. Bye.